Lesson: Data Cleaning, Ensuring Accuracy and Consistency. Ensuring accuracy and consistency in data cleaning is an essential component of the Certified AI Workflow and Automation Specialist course, specifically within the Data Collection and Preparation section. Data cleaning, often referred to as data cleansing or scrubbing, is the process of detecting and correcting corrupt or inaccurate records from a dataset. It is a critical step because the quality of data directly affects the outcomes of any data-driven process, including machine learning, analytics, and automation projects. A pertinent starting point in data cleaning is understanding the common issues that affect data quality. Inconsistencies such as duplicate records, incomplete data, wrong formats, and inaccuracies like typos or outdated information must be identified. Detecting these issues requires a keen eye and a structured approach. Professionals often employ data profiling to identify potential problems. Data profiling involves analyzing the data to understand its structure, content, and interrelationships. Tools like OpenRefine and Talend provide robust capabilities for data profiling and initial cleaning steps, allowing users to identify duplicates, inconsistencies, and anomalies efficiently. One of the initial actionable steps in data cleaning is handling missing data. Missing data can occur due to various reasons, such as data entry errors or incomplete data collection processes. Ignoring missing data can lead to biased results and inaccurate models. There are several strategies to address missing data, including deletion, imputation, and analysis adjustments. Deletion is straightforward, but may not be suitable if it leads to significant data loss. Imputation, on the other hand, involves replacing missing values with estimated ones, using methods like mean substitution, regression imputation, or more sophisticated techniques like multiple imputation. Software like R and Python's Pandas library offer built-in functions to handle missing data effectively, allowing users to apply these imputation techniques seamlessly. Consistency in data is equally crucial, especially when dealing with datasets from multiple sources. Inconsistent data can arise from variations in data entry practices, such as different date formats or units of measurement. Standardizing these formats is essential to ensure that all data entries are comparable. For instance, if a dataset contains dates in various formats, converting them into a single, standard format using tools like Python's datetime module can resolve inconsistencies. The same applies to categorical data, where variations in spelling or capitalization can be normalized using functions available in tools like Excel or Python's Pandas. Beyond these foundational techniques, advanced data cleaning involves more complex transformations and validation checks. Data validation ensures that the data adhere to specified rules or constraints. This process can be automated using tools such as SQL, which allows users to enforce constraints on data entries, or with data validation features in Excel that restrict the type of data that can be entered into a cell. For example, ensuring that a column meant for email addresses contains only valid email formats can be achieved with regular expressions, which are supported in many programming languages and data processing tools. Pause. A practical framework for data cleaning is the CRISP-DM model, which provides a structured approach to data mining and cleaning. The model emphasizes the importance of understanding the data and its context before diving into cleaning processes, ensuring that the cleaning efforts align with the goals of the data project. Using CRISP-DM, data professionals can systematically approach cleaning by iteratively refining data as new insights are gained throughout the data analysis process. Case studies provide insight into the real-world application of these data cleaning techniques. For example, a healthcare analytics project may involve merging patient data from different hospital systems, each using distinct formats for medical codes and patient identifiers. In such a scenario, data cleaning would involve standardizing these formats and resolving any discrepancies. Tools like Apache Spark can handle large-scale data transformations efficiently, facilitating the cleaning and integration of vast datasets. Statistics underscore the importance of data cleaning. According to a study by Experian, 91% of businesses suffer from data errors, which can result in an average loss of 12% in revenue. These figures highlight not only the prevalence of data quality issues, but also their significant impact on business performance. Addressing these issues through rigorous data cleaning practices is not just a technical necessity, but a strategic imperative. In addressing real-world challenges, it's crucial to adopt a mindset of continuous improvement. Data cleaning is not a one-time task, but an ongoing process that evolves with the data and its applications. Regular audits of data quality and the implementation of automated cleaning routines can help maintain high standards of data integrity. Tools like Data Cleaner and the data quality features in platforms like Informatica offer functionalities for scheduled data quality assessments, allowing organizations to stay ahead of potential data issues. The importance of data cleaning extends beyond immediate project needs. Clean, consistent data form the backbone of reliable AI models and automation systems. Inaccurate data can lead to faulty predictions, poor decision-making, and ultimately, a loss of trust in data-driven solutions. By investing in robust data cleaning processes, organizations can enhance their data's reliability, leading to more accurate insights and better strategic decisions. In conclusion, data cleaning is a fundamental aspect of the data lifecycle, particularly in the context of AI workflows and automation. By employing practical tools, adhering to structured frameworks, and focusing on actionable strategies, professionals can significantly improve data quality. This not only enhances the accuracy and consistency of their analyses, but also maximizes the value derived from data-driven initiatives. As data continues to grow in volume and complexity, the skills and techniques associated with effective data cleaning will remain indispensable to any data professional's toolkit.